gas in a refrigerator. Objectives. At the end of this video, you can be able to flare and make additional charging tube in the compressor. Brace compressor charging tube with flared copper tube. Connect the compressor charging tube with the gauge manifold and nitrogen cylinder. Charge dry nitrogen gas into the system. Test the leak with a soap solution. Brace the leak spots. Connect the system with the vacuum pump. Dehydrate the system. Evacuate the system on the both high and low sides. Gas charging into the system. Pinch the system. Let us collect the material and equipment required to do this practical. Number 1. Combination plier, 1 number. Number 2. Cylinder key, 1 number. Number 3. Digital thermometer, 1 number. Number 4. Gauge manifold with LP or HP gauges, 1 set. Double-ended spanner, 1 set. Adjustable spanner, 10 inches, 25 cm, 1 number. Flaring block with yoke, 1 set. Conventional refrigerator, 1 number. Frost refrigerator, 1 number. Vacuum pump, 2-stage, 1 number. Refrigerant gas cylinder, 1 number. Nitrogen cylinder with 2-stage regulator, 1 number. Soap solution as required. Procedure. Task 1. Flare and make additional charging tube in compressor conventional refrigerator. Step 1. Make sure that there is no gas in the system. Through the charging tube of compressor, it should be open. Step 2. Take the copper tube 6 mm soft 1/4 OD. Flare one end with flaring block and yoke. Step 3. Insert the flare nut 6 mm through the copper tube 6 mm at non-flared end. Step 4. Insert 15 mm the non-flared end of copper tube 6 mm into the compressor process tube. Note, this practical exercise to be done after leak testing of the unit or appliance. Ensure that the unit or appliance is already leak tested. Step 5. Fix the angle valve inlet port to the compressor process additional tube flare nut. Step 6. Tighten the joint angle valve flare nut by using a suitable double-ended spanner and adjustable spanner. Step 7. Make sure that the angle valve is closed. Procedure. Task 2. Brace compressor charging tube with additional flared copper tube. Step 1. Take the gas welding bracing set. Step 2. Open the valve of the oxygen cylinder and regulate pressure. Step 3. Open the valve of LPG cylinder and regulate pressure. Step 4. Light up the bracing torch and set the flame neutral type. Step 5. Take the flame to the point of the compressor charging tube with an additional copper tube 6 mm. Step 6. Brace the point with a bracing rod, copper. Step 7. Allow the point to cool down. Task 3. Connect compressor charging tube with gauge manifold and dry nitrogen gas cylinder. Step 1. Connect flare nut of additional charging tube with flare union 6 mm. Step 2. Connect the other end of flare union with charging hose. Step 3. Connect the other end of charging hose with HP high pressure port of gauge manifold. Step 4. Connect the intermediate port of gauge manifold with another charging hose. Step 5. Connect the other end of charging hose with outlet part of nitrogen cylinder. Task 4. Charge dry nitrogen gas into the system. Step 1. Make sure that all thread or screw points are in tight fit position. Step 2. If not, make the joints tighten by using cutting plier to tighten charging hose, double-ended spanner and adjustable spanner to tighten flare nuts, flare unions. Step 3. Open the nitrogen cylinder valve using valve key. Step 4. Regulate the pressure to 50 psi in the pressure regulator. Step 5. Open the knob of high pressure port of gauge manifold by turning the knob gently in anti-clockwise direction. Step 6. Observe the nitrogen gas flowing into the system through notice the reading in HP gauge of manifold. Step 7. Allow the nitrogen flow for 15 to 20 seconds. Step 8. Close the knob of gauge manifold by turning it gently clockwise direction. Step 9. Observe the reading in the pressure gauge HP manifold. Step 10. If the pressure not reached 150 psig, again allow nitrogen flow into the system through reopening the knob of manifold. Step 11. When the pressure reaches 150 psi, close the valve of nitrogen cylinder. Close the regulator knob. Step 12. Close the knob of gauge manifold. Step 13. Take the dry bulb thermometer and find the temperature of ambient air. Step 14. Note down the time. Step 15. Tabulate the readings in the tabular column which is given at the end of this exercise. Step 16. Remove the charging hose. Second, which interconnects gauge manifold and nitrogen cylinder. Step 17. Close the intermediate port of manifold by dummy nut brass 6 mm. Task 5. Test leak with soap solution. Step 1. Take a plastic or metal mug filled with pure water 500 mm. Step 2. Add 25 ml of soap solution concentrate into the water. Step 3. Still mix well and make lather by a paintbrush. Step 4. If the lather is not sufficient, add some more soap solution into the mixture. Step 5. Soak the sponge into the soap solution mixture. Step 6. Take few quantity of soap solution mixture by the brush and apply the solution on the points. Switched joints, charging hose adapters, flare nuts, etc. Braced joints. Place where copper tubes are joined together. Step 7. Take the sponge with solution and lather. Place it under the joints. Step 8. Carefully watch any nitrogen bubbles are coming from the system through the soap solution mixture. Step 9. If no bubbles present, it indicates there is no leak. Step 10. If any bubbles present in the joint, add more soap solution on the joint and find where it is coming from exactly. Step 11. If the leak at screwed or threaded joints, flare nuts, charging hose adapters, make it tight fit and arrest the leak by using double-ended spanner or adjustable spanner or cutting plier. Step 12. If the leak at braced joints, copper tube, confirm the leak and note down the carry-out repairs. Step 13. If there is no leak in screwed or braced joints, leave the system as it is to hold the pressure for next 24 hours. Step 14. After 24 hours, note down the reading, pressure, ambient temperature and time. Step 15. Compare the reading of pressure with previous day's reading. Step 16. If there is no difference between the two readings or there is 5 to 10 psi difference between two readings, the system has no leak. Task 6. Brace the leak spots. Step 1. Leaks if any in braced joints, mark the spots. Step 2. Let out nitrogen pressure from the system. Step 3. Clean the leak spots with emery papers. Step 4. Light the brazing torch, use goggles. Step 5. Heat top and bottom joints of leakage pipes. When it get red hot, apply flux and apply copper rod. Step 6. Stop the welding torch. Let the brazing joint cool. Step 7. Pressurize the system with dry nitrogen. Step 8. Check leak with soap water on all braced joints. Step 9. If there is no leak, vent the nitrogen pressure. Task 7. Connect the system with vacuum pump. Step 1. Connect one end of charging hose 1 to the outlet of angle valve. Tighten the joint with a cutting plier. Step 2. Connect the other end of charging hose to LP low pressure port of gauge manifold. Step 3. Connect one end of charging hose 2 to the intermediate port of gauge manifold. Step 4. Connect the other end of charging hose 2 to the inlet port of the vacuum pump. Step 5. Close the HP high pressure port of gauge manifold with a brass flare dummy nut 6 mm. Step 6. Tighten the screwed or threaded joints by using cutting plier for charging hoses, suitable double-ended spanners for flare nuts, dummy nuts, etc. Step 7. Make sure that the HP or LP knobs of gauge manifold are closed. Recap. In this video, so far we have discussed how to number 1. Flare and make additional charging tubes in the compressor. Number 2. Brace compressor charging tubes. Number 3. Connect the compressor charging tube with the gauge manifold and nitrogen cylinder. Number 4. Charge nitrogen gas into the system. Number 5. Test the leak with a soap solution. Number 6. Brace the leak spots. Number 7. Connect the system with a vacuum pump. Thank you for watching. Have a good day. In the last video, we have discussed on flare and make additional charging tubes in the compressor. Brace compressor charging tubes. Connect the compressor charging tube with the gauge manifold and nitrogen cylinder. Charge nitrogen gas into the system. Test the leak with a soap solution. Brace the leak spots. Connect the system with a vacuum pump. In continuation of this, in this video, we are going to discuss how to know evacuation gas charging and finally pinching the copper tube. Handle and operate the vacuum pump. Dehydrate the system. Evacuate the system on both the high and low sides. Gas charges into the system. Pinch the system. Task 1. Handle and operate vacuum pump. Step 1. Ensure that the power electrical supply available to the vacuum pump by using an online tester. Step 2. Connect the electrical power line of the vacuum pump to the power source, test board or switchboard. Step 3. Switch on the vacuum pump. Step 4. Open the valve knob, LP port of gauge manifold. Step 5. Open the angle valve by turning the system to anti-clockwise direction with ratchet key or wrench. Step 6. Observe the pressure reading available on the LP gauge of manifold. The pressure gets reducing. Step 7. Leave the system as it is for 2 hours without any interruption. Task 2. Dehydrate the system. Step 1. Take the heating kit infrared lamp and switch it on. Step 2. Make sure that the system is getting vacuum and the pump is functioning. Step 3. Heat all over areas of the system with infrared lamp. Step 4. Apply heat uniformly to all areas. Refrigerant tubes, condenser coil, evaporator coil if it is exposed, liquid line dryer or filter. Step 5. Keep and maintain the distance between the heating kit and surface of the system 15 cm always. Step 6. Continue the process for 15 to 30 minutes. Task 10. Evacuate the system. Step 1. Notice and observe the pressure reading on the LP gauge of the manifold. It should be 100 microns or below, equivalent 30 in of Hg. Step 2. Close the angle valve by turning its system to clockwise direction with ratchet key or wrench after 3 hours from the time of vacuum pump started. Step 3. Close the LP knob of gauge manifold. Step 4. Switch off vacuum pump and disconnect the power supply. Step 5. Disconnect charging hose 1 from angle valve. Step 6. Close the outlet of angle valve with dummy nut 6 mm. Tighten the nut with a suitable size double-ended spanner. Step 7. Disconnect charging hoses 1 and 2 from gauge manifold and vacuum pump. Task 11. Gas charging the system. Step 1. Charge refrigerant in hermetic refrigeration system of a conventional refrigerator. Step 2. Charge refrigerant in hermetic refrigeration system of a frost-free refrigerator. Step 3. It is assumed that the unit or appliance which is going to get charged is under or holding vacuum. Task 12. Connect the system to charging cylinder. Step 1. Connect one end of a charging hose 1 to the valve of charging cylinder and connect other end to intermediate port of cage manifold. Step 2. Connect an end of charging hose 2 to the angle valve of compressor and connect other end to low pressure LP port of cage manifold. Step 3. Close the high pressure HP of cage manifold with a flare dummy nut 6 mm and tighten it using a suitable double-ended spanner. Step 4. Ensure that the charging cylinder valve, LP and HP valve knobs of cage manifold and compressor angle valves are closed. Step 5. Tighten the ends of charging hoses using a cutting plier. Task 13. Purge air in the charging hoses. Step 1. Open the charging cylinder valve gently or slowly by turning the knob 1/2 to turn to anti-clockwise direction. Step 2. Purge the charging hose 1 by loosening its end at the intermediate port of cage manifold using a cutting plier. Step 3. Observe the refrigerant is escaping out at intermediate port of manifold in form of snow. Then immediately tighten the end of charging hose and ensure that the escape or release of refrigerant is arrested. Step 4. Open 2-3 turns the LP knob of cage manifold and observe the reading on the LP gauge. Step 5. Purge the charging hose 2 by loosening its end at the angle valve using a cutting plier. Step 6. Observe the refrigerant escape, then immediately tighten the end of charging hose 2 to arrest the refrigerant flowing out. Task 14. Charge refrigerant into the system. Step 1. Note down the level of refrigerant in the charging cylinder and record it in the tab column. Step 2. Open the stem of angle valve at compressor process line by slowly turning the system to anti-clockwise direction using ratchet key or wrench. Step 3. Observe the refrigerant flow in the charging tube of the compressor by touching it with hand or finger. Ensure the refrigerant flow by feeling the charging line is cold. Step 4. Observe the refrigerant flow or transfer by watching the level in the charging cylinder. Step 5. Leave the system as it is for 3 to 5 minutes or till all refrigerant or required quantity of refrigerant to settle into the system. Step 6. Close the valve of charging cylinder after ensuring the refrigerant is transferred into the system. Step 7. Close the LP knob of cage manifold by turning the knob to clockwise direction using hand. Step 8. Close the angle valve by turning its stem carefully to clockwise direction using ratchet key and adjustable spanner. Step 9. Observe and record the reading on the charging cylinder to calculate the amount of refrigerant is charged. Step 10. Disconnect charging hose 2 from the angle valve. Task 15. Connect system to service cylinder. Gas charging in refrigeration systems can be done using various methods including the weight method, pressure method and temperature method. Place the refrigerant cylinder in the weighing machine and note down the values in kilograms. Open the valve on the refrigerant cylinder slightly to allow refrigerant to flow into the system. Add refrigerant slowly and periodically check the pressure readings on the manifold gauge set. Step 1. Connect an end of charging hose 1 to the valve of service cylinder and connect the other end to the intermediate port of cage manifold. Step 2. Connect one end of charging hose 2 to the angle valve of the compressor and connect other end of the low pressure LP port of cage manifold. Step 3. Close the high pressure HP port of cage manifold with a flare dummy nut 6 mm and tighten it using a suitable double-ended spanner. Task 16. Purge air in the charging hoses. Step 1. Open the service cylinder valve by slowly turning its stem 1/2 to turn 1 to anti-clockwise direction using a ratchet key or wrench. Step 2. Purge the charging hose 1 by loosening its end at the intermediate port of cage manifold using a cutting plier. Step 3. Observe the refrigerant is escaping out at the intermediate port of manifold in the form of snow. Then immediately tighten the end of charging hose 1 and ensure that the escape or release of refrigerant is averted. Step 4. Open 2 to 3 turns the LP knob of gauge manifold and observe the reading on the LP gauge. Step 5. Purge the charging hose 2 by lessening its end the angle valve using a cutting plier. Step 6. Observe the refrigerant escape, then immediately tighten the end of charging hose 2 to arrest the refrigerant flowing out. Hydrocarbon gases have a wide flammable range, meaning they can ignite at relatively low concentrations in the air. Even a small leak or accidental release of hydrocarbon gas in a confined space like a refrigerator could create a potentially hazardous situation. When handling hydrocarbon gases, it's essential to follow strict safety protocols. Task 17. Charge refrigerant into the system. Step 1. Open the angle valve stem, a compressor process line, by slowly turning it to anti-clockwise direction using a ratchet key or valve key. Step 2. Observe the refrigerant flow in the charging tube of the compressor by turning it with hand or finger. Ensure the refrigerant flow by feeling charging line is cold. Step 3. Observe the refrigerant flow also in LP gauge of manifold. The pressure is increasing from vacuum level -30 in Hg to above 0 psig onwards. Step 4. Observe the hissing noise into the compressor using the pressure increasing from vacuum to above 0 level. It indicates the vacuum is braked. Step 5. Allow the refrigerant flow till it reaches 30 to 50 psig in the LP gauge of manifold. Then immediately close the angle valve. Step 6. Ensure that the wiring of the system or appliance is ready for switch on using wiring diagram. Step 7. Test the electrical power supply available to the appliance is in operating limits 180 to 230 volts, amperes, watts using a clamp meter or tongue tester. Task 18. Pinch the system node. Step 1. Pinching may require either on low side or high side. Sometimes it requires at both sides, suction or process line and liquid line. Step 2. System to be in working condition when pinching at low side and system to be kept off position when pinching at high side. Step 3. Use of proper tools like pinching block or pinch off tool handheld type must be compulsory to carry out pinching process using cutting or nose pliers as pinching tools to be strictly avoided as it may not serve the purpose. Step 4. Wear eye goggles and hand gloves whenever necessary. Step 5. Ensure that the compressor is working. Step 6. Pinch the line between compressor process tube and flare nut of angle valve using a pinching tool. Step 7. Hold the pinching tool tightly on the process line. Step 8. Remove the angle valve by loosening it from the flare nut using an adjustable spanner and a suitable size double-ended spanner. Step 9. Cut the copper tube between the flare nut and pinching point using a tube cutter. Step 10. Test leak refrigerant at open end of copper tube beyond the pinching point by applying thin film of soap solution into the open end. Step 11. Arrest leak if found by extra tightening of pinching block or double crimping the handheld pinching tool. Once charging is completed, monitoring temperature, current, voltage, and pressure helps ensure that the refrigerator's cooling system is operating within its designed parameters. Hi everyone! In today's video, let us know how to make a wiring circuit for a refrigerator. Objectives: at the end of this video, you will be able to trace the electrical wiring circuit in refrigerator system. Let us collect the tools and equipment required to do this exercise. Trainee's toolkit 1 set. Line tester 1 number. Nose plier 1 number. Test cords 5 meters. Test lamp, 1 number. Soldering iron, 1 number. Multimeter, 1 number. Clamp meter, 1 number. Fin straightener, 1 number. Sandpaper as required. A complete system of RSIR circuit, CSIR circuit, 1 number. Task 1. Check electrical wiring RSIR operation. Step 1. As per the circuit, check that the bulb with the switch is connected parallel to the power supply. The purpose of this switch is to detect when the refrigerator door is opened or closed. Step 2. Check that the protector is connected with the phase terminals of the power supply in series to the compressor along with the relay. The overload protector is connected in series with the compressor. It is part of the electrical circuit that provides power to the compressor motor. These devices are designed to protect the compressor, which is a critical component in the refrigeration system. The overload protector may have a manual reset button. If the protector trips, the manual reset button needs to be pressed to restore power to the compressor. Step 3. Check that the overload protector is connected to the current relay contacts as per the circuit diagram. In a refrigerator system, the overload protector and the current relay work together to protect the compressor and ensure efficient operation. The current relay is another device connected in series with the compressor. It is responsible for controlling the starting and running of the compressor motor. The compressor motor has 2 windings, a start winding and a run winding. The current relay is involved in switching between these windings during the starting and running phases of the compressor. When the refrigerator is turned on, the current relay plays a role in the starting sequence of the compressor. It helps energize the start winding to initiate the compressor's rotation. Once the compressor is up and running, the current relay may switch to the run winding for continued operation. Step 4. The external overload switch is usually located on the exterior of the compressor housing. It may be a separate component connected to the compressor or integrated into the compressor's design. It interrupts the flow of electrical current to the compressor when it senses that the temperature or current draw is reaching unsafe levels. Step 5. In a refrigerator system with RSIR, relay start induction run compressor, the thermostat is a key component in controlling the temperature inside the refrigerator. The thermostat connected to the compressor contains a temperature sensing element, such as bimetallic or a gas-filled bulb. Volatile liquid filled. This element responds to changes in temperature inside the refrigerator. In a refrigeration system, the thermostat is used to control the internal temperature by regulating the operation of the cooling system. When the temperature sensed by the thermostat deviates from the set point temperature, the thermostat sends a control signal to the cooling system and cuts off the compressors. The thermal bulb of the thermostat may indeed be located on the back side of the evaporator coil. There are 3 names for this element. Number 1. Sensing bulb. Number 2. Remote bulb. Number 3. Feeler bulb. The thermal bulb is a small sealed chamber attached to the thermostat, usually located within the refrigerated space or in close proximity to it. Inside the thermal bulb is a volatile liquid such as refrigerant or a similar substance with high thermal sensitivity. Check the electrical wiring CSIR operation. Step 1. In the CSIR, capacitor start induction run motor refrigeration system, a door bulb with a control switch is connected in parallel to the power supply. Step 2. The thermostat switch and current relay are connected in phase terminal and series to the capacitor. Start induction run motor in the refrigeration system as shown in the circuit diagram. Step 3. In CSIR, identify the starting and running winding of the motor by measuring the resistance values using a multimeter. Step 4. Ensure that the starting capacitor is connected in series with the starting or auxiliary winding. Number 1. The capacitor helps create an artificial phase shift, allowing the motor to generate a starting torque. Without a capacitor, a single-phase motor fails to start. Number 2. A capacitor is often used to improve the motor's starting and running characteristics. Step 5. Check that the common point C in the motor terminal is connected to the overload protector in series. Recap. In this video session, we have learned how to trace the electrical wiring circuit in the refrigerator system. Hi everyone. In today's video, let us know how to install a refrigerator. Objectives. At the end of this video, you will be able to: Number 1. Uncrate or unpack the refrigerator unit. Number 2. Select the location of the unit. Number 3. Position the unit. Number 4. Test the electrical power supply. 5. Connect the voltage stabilizer to the unit. Number 6. Start the refrigerator unit. Number 7. Test the performance of the unit. Let us collect the tools and equipments required to do this practical. Spirit level meter 1 number, multimeter 1 number, line tester 1 number, combination plier 1 number, wire stripper 1 number, screwdriver 150 mm 1 number, adjustable spanner 150 mm 1 number, thermometer stem or digital type -5 to +50 degrees Celsius 1 number, clamp meter 0 to 10 amperes 1 number, domestic refrigerator 1 number, voltage stabilizer 1 number. Procedure. Task 1. Uncrate or unpack the refrigerator unit. Step 1. Place the unit in upright position on a flat even surface carefully. Step 2. Cut the packing tape or rope using wire stripper or small knife. Step 3. Remove the outer cover or crate by lifting it from bottom to top very carefully. Caution. Beware of condenser coil if it is backside. If any damage occurred on it may lead to gas leak. Step 4. Remove extra packing materials if it is there. Step 5. Watch carefully the outer surface of unit. The outer body should be clean and glossy and without any scratches, dents, etc. Step 6. Remove the base packing wood by unscrewing the bolts and nuts using a suitable double-ended spanner or adjustable spanner. Note: keep safe the unit inclined position while removing the base bolts. Step 7. Keep the unit away from packing materials. Task 2. Select the location. Note: normally, unit location will be decided before the unit is arrived to the place, so that proper wiring and plug point will be made accordingly. Step 1. Ensure that the location has sufficient air ventilation. Step 2. Ensure that electrical power point available near the unit. Step 3. Ensure that there is no any heat emitting or radiating units, gas stoves, heaters, sunlight, etc. nearby the location. Step 4. Ensure that the flow level should be strong and flat even surface using spirit level. Task 3. Position the refrigerator unit. Step 1. Place the unit on the selected location. Step 2. Keep 1 foot or more space between the wall surface and rear side of the unit. If condenser is in back side, external type. Step 3. Keep 1 foot or more space between the wall surface and both sides of the unit. If the condenser is built in, internal type. Step 4. Keep sufficient space in front side for opening the door fully. Task 4. Test the electrical power supply. Step 1. Test the availability of electrical power using online tester by inserting its tip into the socket. Step 2. Measure the voltage rate using a multimeter, tongue tester, or voltmeter by inserting the probes, phase and neutral into the socket. Step 3. Ensure the rated or measured voltage is in operating range of compressor of the unit, 180 to 230 volts. Step 4. Use voltage stabilizer if the voltage is out of range or fluctuating. Step 5. Ensure proper earthing is made in the socket. Task 5. Connect voltage stabilizer. Note, it is always advisable use voltage stabilizer correct capacity not only in the places of low voltage or fluctuating. Use it everywhere with every units to save the compressor from sudden voltage fluctuations and maintain constant voltage to the compressor. Step 1. Unpack the voltage stabilizer. Step 2. Notice the outer surface of stabilizer for any defects like sheet metal bulge, scratches, etc. Step 3. Make sure that the pointer of the voltmeter of stabilizer at 0 reading only, or make sure the voltmeter has no error. Step 4. Insert the 3-pin plug of the stabilizer into the socket. Step 5. Switch on the socket. Step 6. Ensure the LED bulb for main on close if provided. Step 7. Observe the voltage limits of input and output by pressing the selector switch. Note, normally the voltage stabilizers for refrigerators or air conditioners are available with time delay, 3 minutes start. So the output voltage may come after 3 minutes from time it is switched on. Task 6. Start the refrigerator unit. Step 1. Open the doors of the unit and see the internal conditions. It must be clean and dry. Step 2. Keep the door open for 2 minutes for replacing existing cabinet air with ambient air. Then close the door. Step 3. Make sure that the stabilizer is off position. Step 4. Insert the 3-pin plug of refrigerator into the output socket. Step 5. Switch on the stabilizer. Step 6. Wait for 3 minutes to start the unit if the stabilizer has time delay facility. Step 7. Observe the refrigerator gets on by hearing mild noise, 30 to 35 decibel due to compressor is started. Task 7. Test the performance of the unit. Step 1. Ensure that the doors of the unit closing well. Step 2. Make shelves in the cabinet with the materials which are given separately or along inside of the unit. Step 3. Fill water at normal room temperature in the ice tray which will be in freezer section. Step 4. Observe the bulb or light in the cabinet closed during the door kept open. Step 5. Set the thermostat knob to normal position between low cool and high cool position by turning it clockwise or anti-clockwise direction as required. Step 6. For conventional ordinary refrigerator, feel the chillness by keeping the hands over inner surface of the freezer. For frost-free refrigerators, feel the chillness by keeping the hands before the air breeze at the fan motor which is in the freezer. Step 7. Put the sensing probe of digital thermostat inside the freezer and start watching the reading in the display outside. Step 8. Keep the freezer door and cabinet doors closed for some time, 2 hours. Let the unit run without any interruption for 2 hours. Step 9. Open the refrigerator door and observe the cooling in the cabinet by feeling. Step 10. Open the freezer door and ensure that the water which is filled earlier 2 hours before became ice. Step 11. Set the thermostat knob to low position. Step 12. Keep the door closed and wait for some more time, 30 minutes. Step 13. Observe the unit compressor trips. Step 14. Fill up the checklist as per the contents. When checking the performance of the refrigerator, voltage, current, watts, temperature of the evaporator coil, and vibration in the condenser are also to be checked. Hi everyone! In today's video, let us know to check for faults and test the electrical and other system components of a refrigerator. Objectives: at the end of this video, you will be able to: Number 1. Check and test the current coil relay. Number 2. Check and test the overload protector. Number 3. Identification of compressor winding terminal pins with an ohm meter or test lamp or clamp meter. Number 4. Check the short circuit in the compressor. Number 5. Check the condition of a door switch. Number 6. Check the thermostat. Number 7. Check the capacitor. Let us collect the tools and equipment to do this exercise. Screwdriver 10 mm tip, 200 mm length, 1 number. Cutting plier 200 mm, 1 number. Nose plier 1 number. Phillips screwdriver set, 1 number. Ohm meter or multimeter, 1 number. Clamp meter, 1 number. OLP overload protector, 1 number. FHP fractional horsepower compressor, 1 number. Test board fitted with voltmeter and ammeter, 1 number. Capacitor, 1 number. Sandpaper as required. Insulation tape, 1 number. Procedure: Task 1. Test the current coil relay. Step 1. Check continuity between the 4th and 5th with the help of ohm meter or multimeter. Step 2. If the continuity is okay between 1 and 2, coil continuity of current coil relay is okay. Normal condition 4 and 5 continuing will be there. Step 3. Check continuity between 5 and 6. Normal condition when not in use, 5 and 6 open. If there is no continuity between 5 and 6, relay is okay. Step 4. Keep the relay upside down. Check continuity between 5 and 6. If the continuity is there, relay is okay. Step 5. Bring to its original position. Check continuity between 2 and 3. If there is no continuity, relay found okay. Step 6. Check plunger movement and observe sound. Keep the relay upside down. Plunger moves up and you can hear the sound. Bring to normal position. Plunger comes down. You can hear sound. If there is no sound, relay is defective. Relay plunger operating is not okay. Task 2. Check and overload protector. Step 1. Check continuity between 1 and 3. Step 2. If the continuity okay between 4 and 5, continuity of bimetal contacts okay. Step 3. If there is no continuity, overload is defective. Step 4. Check any rust formation in disc. If rust formation is there, not advisable to use. Task 3. Identification of compressor winding. Terminal pins with ohm meter or clamp meter of fraction horsepower hematic compression. Before carrying out the exercise, remember the following. Running winding resistance always less than starting winding. Starting winding resistance always higher than running winding. Resistance of run and starting winding, sum of starting winding resistance and running winding resistance. Set your multimeter to the resistance ohms mode. Touch one multimeter probe to one of the motor's terminals and the other probe to one of the remaining terminals. The terminal that shows the lowest resistance to both other terminals is likely the common terminal. This is because the common terminal is connected to both windings and measuring across it will show the combined resistance of both windings and note down the readings. Step 1. Set the ohm meter in resistance at low range. Step 2. Measure the resistance between A and C, 20 ohms. Step 3. Measure the resistance between A and B, 40 ohms. Step 4. Measure the resistance between C and B, 60 ohms. and record the values in the tabulation. Step 5. Identified A terminal pin becomes common terminal. Step 6. Identified B terminal pin becomes starting winding. Step 7. Identified C terminal pin run winding. Resistance values slightly vary from manufacturer to manufacturer. Instructor must have compressor manufacturer specification. Task 4. Check short circuit in compressor. Step 1. Check the multimeter to resistance mode at the appropriate range. Step 2. Place A probe to compressor terminal. Step 3. Place B probe to metal casing of compressor. Step 4. Check continuity. If continuity is there, compressor grounded. Step 5. If there is no continuity, compressor not grounded. Task 5. Check the condition of a door switch. Step 1. Switch on the refrigerator. Step 2. Open the refrigerator door and check the condition of cabinet bulb. It should glow. Step 3. If it is not, check the bulb. Step 4. If the bulb is fused, replace the bulb on refrigerator and check. Step 5. Still the bulb not glows, then switch off the refrigerator and remove the door switch and disconnect the wires. Note: mark all connections which are being disconnected. Step 6. Check the continuity in switch by multimeter or by test lamp is on and off position. Step 7. Check bulb holder wires. Step 8. If switch found defective, replace it and connect wires. If found necessary, add salt and ice cubes from time to time. Take out salt water from the insulated container from time to time to obtain correct temperature. Precaution: while handling the thermal bulb, do not bend the capillary too sharp as it may break. Task 6. Carry out a test on thermostat. Step 1. Crush ice cubes and place it in an insulated container. Step 2. Mix some salt to the crushed ice cubes. Step 3. Insert a thermometer inside the container. Step 4. Take a thermostat and check electrical contact points. If necessary, clean the contact points with fine sandpaper. Step 5. Connect 2 wire leads to the thermostat. Step 6. Connect a bulb in series with thermostat. Step 7. Connect the other end wire leads with 2-pin plug and plug it in test board and switch on. Step 8. Check that the light glows when the knob of the thermostat is not in stop position. Step 9. If the light is not glowing when the knob of the thermostat is in stop position. Step 10. Adjust the knob to on position. Step 11. Watch the reading of the thermometer. Step 12. See that the 100 watts bulb glows all the time. Step 13. Wait till thermostat goes to cut off, which will be indicated by off position of the light. Quickly take the reading of the thermometer. Step 14. Remove the thermal bulb from the ice cubes. Step 15. Hold the thermal bulb by hand and warm it when the thermostat goes to cut in position, which will be indicated by the glowing of the 100 watts bulb. Step 16. Note the temperatures for 3 different readings carefully and record in tabulation. In a single and dual door refrigerator systems, a thermostat is present. In a 3 and 4 door refrigerator system, a thermistor will be present on the PCB board. Start by visually inspecting the PCBs for any signs of damage, such as burn marks, discoloration, or corrosion. Check for loose or damaged components, connectors, and solder joints. Task 7. Check capacitor. Caution: do not place fingers across the terminals of a capacitor. It may be charged and gives a shock. Short it with an insulated wire before handling. Step 1. Remove the capacitor for test. Step 2. Connect the capacitor in capacitor test circuit. Step 3. Check the fuse D in the circuit as shown. Step 4. Switch on the circuit plug E. If the capacitor does not take a charge, it will not spark. This indicates an open circuit. The capacitor is connected to the terminals of the tester. Step 5. press the charging switch B for 1 or 2 seconds. Step 6. Put off the circuit plug E. Step 7. With the switch open at B, touch the shorting switch C. If the capacitor is good, the switch will spark. Step 8. If it does not spark in the first time, try it 2 or 3 times before replacing the capacitor to the unit. Note, if the capacitor is good, it will spark. If the capacitor is shorted or grounded, the fuse T will blow as in view. Caution, the capacitor should be put in a protective case while testing it because a short capacitor may explode when put in a circuit.
Recap. In this video session, so far we have discussed how to check out for faults and test the electrical and other related system components of a refrigerator. Hi everyone, in today's video, let us learn how to test a compressor and identify the motor terminals. Objectives. At the end of this video, you will be able to Number 1. Check compressor hermetic pumping efficiency. Number 2. Check the compressor winding. Number 3. Check the short circuit grounded in the compressor. Number 4. Identify compressor terminals by using test lamps. Number 5. Identification of the compressor winding using an ohm meter or clamp meter.
Let us collect the tools and equipment required to do this practical. Gauge manifold, 1 number. Charging line, 1 number. Ratchet wrench, 1 number. Adjustment wrench, 1 number. Multimeter, 1 number. Insulated nose plier, 1 number. Line tester, 1 number. Refrigerant cylinder, 1 number. Hermetic compressor, high capacity, 1 number. Screwdriver, 200 mm, 1 number. Soldering iron, 65 watts, 1 number. Series test lamp, 1 number. Sealed compressor, small capacity, 1 number. Procedure. Task 1. Check compressor hermetic pumping efficiency. Step 1. Connect the refrigerant cylinder to the process tube of hermetic compressor using a pressure regulator. Step 2. Connect the discharge side of the compressor to a condenser coil having appropriate capacity. Now, connect the other end of the condenser coil to a pressure gauge having a range of 0 to 20.5 kg per centimeter square. Step 3. Check for leakages at all joints using soap solution. Step 4. Supply refrigerant vapor gas at a constant pressure of 150 by 300 psi in the process tube of the compressor. Step 5. Start the compressor and run for few seconds to build a head pressure of valve as given below. On attaining the specified discharge pressure, stop the compressor as in the tabulation. Step 6. Check for drop in pressure for a period of 1 minute and verify whether it falls within specified limit in the tabulation. Step 7. In case the drop exceeds the specified limit, the compressor has a pumping defect. Otherwise, the compressor is perfectly okay. Task 2. Check hermetic compressor winding by multimeter. Terminal pins with ohm meter of fraction horsepower hermetic compression. Before carrying out the exercise, remember the following. Running winding resistance always less than starting winding. Starting winding resistance always higher than running winding. Resistance of run and starting winding sum of starting winding resistance and running winding resistance. Step 1. Set the ohm meter in resistance mode at low range. Step 2. Measure the resistance between A and C 20 ohms. Step 3. Measure the resistance between A and P, 40 ohms. Step 4. Measure the resistance between C and P, 60 ohms. Step 7. Record all the values in the tabulation. Step 8. Identified A terminal pin become common terminal. Step 9. Identified B terminal pin become starting winding. Step 10. Identified C terminal pin one winding resistance value slightly vary from manufacturer to manufacturer. Task 3. Check the short circuit grounded in the compressor. Step 1. Select the ohm meter scale R into 10,000. Step 2. Place the A probe on the compressor terminal. Step 3. Place the B probe in the metal casing of the compressor. Step 4. Check continuity. If there is continuity, the compressor is grounded. Step 5. If there is no continuity, the compressor is not grounded. Task 4. Identify compressor terminals by using test lamps. Step 1. Prepare a test lamp. Connect one end of the lamp to the phase terminal in the test board and the other terminal to any one X of the terminals in the compressor. Step 2. Take a piece of wire. Place one end on the other terminal Y of the compressor and the other end on the neutral and observe the brightness of the lamp. Running and starting minimum brightness. Identified remaining terminals is common. Running and common. Maximum brightness. Identified remaining terminals is starting. XY plus XZ is equals to YZ ohm. Good winding resistance shows the above results. Test and measure the pair of terminals X, Y, XZ, ABD, YZ. They indicate different ohms.
Recap. In this video, we have discussed number 1. Check the compressor's hermetic pumping efficiency. Number 2. Check the compressor winding. Number 3. Check the short circuit grounded in the compressor. Number 4. Identify compressor terminals by using test lamps. Number 5. Identification of the compressor winding using an ohm meter.
Namaskar and a very good morning. I am K.K. Mishra from Ministry of Power, Government of India, and I am here to discuss and talk about the various initiatives taken by Government of India, Ministry of Power regarding digital initiatives. This is a creation of an ecosystem which enables consumer not only to facilitate the various services but also empower and provide better and improved services over a long period of time. So, let's start with the creation of the ecosystem. The basic objective of